Now, in this video, we will going to consider one more case on comparison of hollow shaft and the solid shaft. So we are going to take the comparison of torsional stiffness of hollow shaft and the solid shaft. So first we are going to consider a hollow shaft and a solid shaft, which is made out of same material, length and weight. As the material and weight of the shafts are same, therefore weight is same. So capital WS will be equal to capital WH, and the material is same, which is CS will be equal to CH. So therefore, if you say WS will be equal to WS, that is the weight of the shafts are same, so you're going to have the area into length into specific weight of the material. So that is area of the solid shaft is pi d square by 4 into length of the solid shaft is LS into specific weight of the material is small ws will be equal to the weight of the solid shaft, sorry, the area of this hollow shaft, that is pi by 4 into d naught square minus di square into length of the hollow shaft into the specific weight of the hollow shaft. As we know that the length of the solid shaft and the length of the hollow shaft are same, and also the specific weights of the solid and hollow shafts are same, therefore it automatically it will get cancels there. Therefore pi by 4 and pi by 4 is also gets cancels. Therefore d square will be equal to d naught square minus di square. So taking the d naught square as the common factor into 1 minus di by d naught the whole square. So therefore d naught square will be equal d naught square into 1 minus k square. So if you want to have d, so if you want to specify that it is in terms of d will be equal to d naught into 1 minus d naught into 1 square root of 1 minus k square, where k will be equal to di by d naught, and the length of the solid shaft will be equal to the length of the hollow shaft, and also the specific weight of solid shaft will be equal to specific weight of the hollow shaft. So once you get that expression, so now we need to find out what is the torsion stiffness, because we have to compare the torsion stiffness of the hollow shaft with respect to the solid shaft. So torsion stiffness or torsional rigidity, which is T by theta, which will be equal to C into J into L, C into J by L. So where theta is the unit of angle of twist, and then L small l is the length of the unit length. So therefore, since it is unit length, so that will be gets cancelled. So torsion stiffness will be equal to C into J, where the torsion stiffness of the hollow shaft divided by the torsion of the solid shaft will be equal to CH into JH by CS into JS. As we know that CS is equal to CH, therefore JH will be equal to JH by JS, where JS will be equal to the polar moment of inertia of the hollow shaft divided by the polar moment of inertia of the solid shaft. So what is the polar moment of inertia of the hollow shaft? The polar moment of the inertia of the hollow shaft, which is the pi by 32 into d naught to the power of 4 minus di to the power of 4 divided by pi by 32 into d to the power of 4. By taking pi by 32 is gets cancelled, so taking the common factor of d naught to the power of 4 into 1 minus di by d naught whole to the power of 4 divided by d to the power of 4 can be written in terms of d square into d square. So that why? Because we have the equation for d naught square, d square will be equal to d naught square into 1 minus k square. So you can apply that directly. So that is the reason why we are rewriting the d naught to the d to the power of 4 as d square into d square. So therefore, d naught to the power of 4 into 1 minus k to the power of 4 divided by, substitute the value of d square, which we have found out already, which is d naught square into 1 minus k square into d naught square into 1 minus k square. So d naught square into d naught square, it becomes d naught to the power of 4, and d naught to the power of 4 and d naught to the power of 4 both in the numerator and the denominator will going to be get cancels, and that therefore you will going to get that k will be k can be expressed as di by d naught. So once you do that, so here once d naught to the power of 4 gets cancels, you can write 1 minus k to the power of 4 as 1 minus k square into 1 plus k square divided by 1 minus k square into 1 minus k square. So 1 minus k square in the numerator and also in the denominator gets cancelled. Therefore, 1 plus k square by 1 minus k square, which is all the ratio is always greater than 1, where d will be equal to d naught into square root of 1 minus k square. Therefore, from this expression, what we can say or what we can infer is the hollow shaft is stiffer than the solid shaft when their material length and the weights are same. So this is how you will be able to compare between the solid shaft and hollow shaft and the solid shaft of the torsional stiffness. Thank you.